In this video, we will analyze how to solve a series parallel circuit using superposition. In this circuit, we have two voltage sources, V1 and V2. In order to use superposition, we must analyze the circuit using only one source at a time. For example, in this first circuit we have here, we will analyze it using V1, and we will short out the voltage source V2. Looking at this circuit, we can see that V1 generates I total, and that I total, when it hits this first node, will split into I1 and I2. That tells us that R2 and 3 are in parallel. In order to solve for that equivalent circuit, we can use the product over sum rule. So we have R23 is equal to R2 times R3 divided by R2 plus R3. Substituting in the values we have, that's 1k ohm times 1k ohm divided by 1k ohm plus 1k ohm. Plugging those numbers into a calculator gives us R23, a value of 500 ohms. That creates a circuit that looks like this one. Alright, where we have one current, I total, flowing through R1 and R23, which tells us that R1 and R23 are in series. So we can find the total in step number 2. We can find the total resistance, R total, is equal to R1 plus R23. Substituting in those values, that's 1k ohms plus 500 ohms. Which is a total resistance of 1.5k ohms. Now that we know the total resistance, then in step number 3, we can calculate total current due to the source V1. So I total is equal to V1 divided by R total. This is 6 volts divided by 1.5k ohms yields 4 milliamps. Due to V1. Now, that says I total is 4 milliamps. It flows through R1 and at this junction splits into I1 and I2. We can find the current I1 through R2 by using the current division rule, since R2 and R3 are in parallel. So our step number 4, I1 is equal to I total times R3 divided by R2 plus R3. Substituting the values we have, I total we just calculated was 4 milliamps. R3 is 1k ohm. R2 is 1k ohm. and R3 plus R3, which is 1k ohm also. Plugging these into a calculator tells us that I1 due to V1 is 2 milliamps. So we know the current flowing through R2 is 2 milliamps and it's going down. Alright, now we need to go back and look at the original circuit and analyze it using V2 only. So we'll take that circuit and we'll short out V1 so it has no effect and just analyze this using just V2. Now we've redrawn our currents. I total now comes from V2, and when it gets to the first node here, it's going to split into I1 and to I2. Again, using the same reason as before, that tells us that R1 and R2 are in parallel. We can find that equivalent resistance. R12 is equal to R1 times R2 divided by R1 plus R2. Substituting, we have 1K ohm times 1K ohms divided by 1K ohm plus 1K ohm. This comes out to be 500 ohms, which reduces the circuit to this equivalent circuit. Now, since we have a series circuit with R3 in series with R2, we can find the total resistance. So this was step 5. So step number 6 is going to be R total is equal to R3 plus R12. Substituting in those values, that's 1K ohm plus 500 ohms. Which gives us an R total, in this case, of 1.5 K ohms. Alright. Now that we know the total resistance, then we can find in our next step our total current generated by V2. So I total here is going to be equal to V2 divided by R total, which is equal to 3 volts divided by 1.5 K ohms. That yields 2 milliamps generated by I total. So we have 2 milliamps I total flowing to this junction, and then it's going to split between R2 and R1. Alright, we can, in step number 8, we can determine what that current's going to be using, again, the current division rule. So we have I1 is equal to I total times R1 divided by R1 plus R2. This is equal to 2 milliamps times 1k ohm divided by 1k ohm plus 1k ohm. Plugging those numbers into a calculator gives us an I1 of 1 milliamp, and it also is down. Okay, now our final step is to determine the total current through R2. Well, going back up to where we solved the first one, we had due to the source V1, then we had a current of 2 milliamps going down flowing through R2. So the current due to V2 through R2 was 1 milliamp going down. So to figure out the total current, we just simply have to add those together, or if you will, I1 total equals I1 due to V1 plus I1 due to V2. All right, looking up one more time, I1 due to V1 was back up here. That was 2 milliamps down. So that was 2 milliamps plus 1 milliamp down due to V2 and summing those numbers, we have the total current I1 flowing through R2 is 3 milliamps. That concludes the video on superposition.